So what I'm going to talk about is what's called percent yield. And this is something that we're going to use a lot in labs. Let me get it down here. Percent yield. It's a real simple equation. Basically what it is, the percent yield is going to be equal to the experimental amount that you find, during that you make in an experiment divided by the theoretical. And the theoretical would be based on the stoichiometry, the amount of actual product you would make in the best case, situation. And then this is all going to be multiplied by 100. So for example, let's say during an experiment, okay, the reaction that you were going to do, you were going to say, all right, I have some zinc and I'm going to add it to some hydrochloric acid, and the products out of that, it's a single replacement reaction. I'm going to get hydrogen gas and some zinc chloride. Have to go back through and balance it by putting a 2 in front of there. And you started off with, 2 grams of zinc, and you wanted to figure out how much hydrogen gas you were going to form. So according to the theoretical, here I am, I'm calculating the theoretical yield. I would take those 2 grams of zinc, I would change that to moles. 1 mole of zinc has a GFM of 63 grams per mole. I hope that's right. 65. Oops. Alright, go back to that. Get rid of that. 65 grams. According to the balanced equation, I will get 1 mole of hydrogens for every 1 mole of zinc. Since I'm looking for gas, my final conversion out of moles will be the fact that there's 22.4 liters for every 1 mole. Now this is assuming that it's at standard temperature and pressure, which is something we'll get to a little bit later. So anyway, I am calculating my theoretical yield. So it's 2 divided by 65 times 22.4. The theoretical yield would be 0.67 liters. Alright? Now, say I actually did the experiment. I sat there and collected this gas. Actually, it's probably a lab that you're going to do. So I collected it, and I found out that the amount that I experimentally collected was 0.5 liters. Well, there's a difference. Okay, the theoretical is if everything worked perfectly, if every single zinc found every single hydrochloric acid that it needed, and everything went, I didn't lose anything or whatever. This 0.5 liters, though, was the experimental amount that I collected. So the percent yield for this experiment is going to be pretty simple. Percent yield is going to be 0.5 liters divided by 0.69 liters times 100. So 0.5 divided by 0.69 times 100. The percent yield was equal to 72.5%. You don't usually worry about sig figs so much when you're figuring out percentages. There is a convention that says to run it to 2 decimal places. In my opinion, if you run it to 1 decimal place, it's just fine. But that's the way commonly, experiments are handled. Well, I want to do a little bit trickier problem that you're going to get, and it's going to look something like this. Let's say, okay, so here's a reaction. I have um, 2 moles of potassium chlorate, and it's going to decompose into 2 potassium chlorides and 3 oxygens. All right? And you're given the fact that the yield, when you did this experiment, was 95%. Okay? And then it goes on further to say how many grams I just spelled grams wrong. That's pathetic. Grams are needed. Grams of KClO3 are needed to produce 10 liters of O2. All right? So it's kind of a little bit of a complicated problem, but the place that I want to start out is I need to figure out how much I got to get out of this, okay? So what my theoretical yield, if everything went right, I want, I'm not really sure what I want, but I need to get 95% of 10 liters. So it's going to work out like this. So what I'm going to do is I'm going to set up the formula. All right, I have, or the percent yield was 95%. So that's going to equal an experimental amount. Well, the experimental amount is the 10 liters. That's what I'm looking for. So it's 10 liters divided by the theoretical is what I need to calculate. X there times 100. And that's kind of confusing, but the way you got to look at this is when the reaction takes place, 95% of it is going to produce the product, and the product is 10 liters. So I have to figure out what the theoretical amount would be. So solving for X right here, okay, the theoretical yield that I'm going to need turns out to be 10.5 liters. So if I want to produce 10.5 liters of oxygen, go back, figure out how much KClO3 I needed in the first place. So to do that, back to stoichiometry, I'm going to sit there and go, okay, I have 10.5 liters, change it to moles, 1 mole of O2, 22.4 liters. There happens to be 3 moles of oxygen for every 2 moles of KCl. Turns out the gram formula mass of, 2 moles of KClO3, sorry, messed that up. 2 moles of KClO3. The GFM of KClO3 is 122.5 grams for every 1 mole. So now, what I need to have started originally, 10.5 divided by 22.4 times 2 divided by 3 times 122.5 tells me I needed 38.3 grams of KClO3 to start with, that if I get a 95% yield, it will produce 10 liters. This is a little more complicated, but we'll try a couple of these.